Today we will continue looking at the hierarchies of polygons that we were looking at in the previous week. So, we are going to start just by reviewing what a hierarchy is, what polygons are, and then how we can name different types of polygons before we get to our hierarchy riddles today. So, let's take a look. The first word we see is this word hierarchy. We remember that a hierarchy is a classification system or a way of ordering things. We start with a category. Our category in this case is polygons, which are closed shapes with at least 3 sides. So let's start off by classifying our triangles by looking at their hierarchy. We remember that each category can be divided into subcategories like the ones we see here. Subcategory 1 being the number of sides, then the side lengths, and then subcategory 3 is our angle size. So, when we take a look at triangles, we remember that they can be called a bunch of different things. We know they're called a triangle because they're any shape that has 3 sides, but they could be an equilateral triangle with 3 equal sides, an isosceles triangle with 2 equal sides, or a scalene triangle with no equal sides. We can break it down even further from that and find from our isosceles triangle, we can name our triangles by their angles. So they could be obtuse, meaning they have a wide angle. They could be acute, meaning all the angles are smaller than 90 degrees, or it could be a right triangle, meaning that the angle is 90 degrees in at least one of the corners of this triangle. Our scalene triangle will see these same options available. Right for having one right angle, acute for all angles smaller than a right angle, and obtuse for having one angle that is larger than 90 degrees. Okay, so this is something that you will be looking at today. You may need to know for some of your riddles how we classify different triangles. So if you ever get confused, come back to this page. There's 2 different ways for you to see how triangles are named here. But the main part of this that we're thinking about today is how do I name shapes and how do I place them on a hierarchy? So if I wanted to name any of these different types of triangles, I would want to give the most specific name possible. So if I were to draw a triangle that looks like this, I wouldn't just tell my friend, that looks like a triangle. I would think to myself, well, what kind of triangle? I know that I have a right angle, so it's definitely going to be some kind of right triangle, okay? Starting at the bottom of my subcategories, the lowest, the most specific, and then working my way up to the most general. Then I look at the side length and I think, okay, well, these 2 side lengths are equal, so it must be a right isosceles triangle. It has 3 sides, so I know that it has to be a triangle. I could even say it's a right isosceles triangle polygon. Now, that would sound kind of silly, but it would be the correct method of classification, okay? So using triangles as our example, we'll be thinking a lot about these hierarchies today. Now, there's a couple other terms that we need to be familiar with. One is regular polygons, and the other is irregular polygons. A regular polygon has all sides and all angles congruent, meaning all of the sides are the same length, okay? So we see here this hexagon has 6 equal sides, okay? And then we see that our square has 4 equal sides. Our triangle has 4 equal sides, okay? So it has congruent sides and also congruent angles, okay? Congruent, again, meaning equal or the same size. So we see that all of these angles are the same size, okay? You see that everywhere in all of these shapes, even in our square, they're all 90 degrees. Now, when I look at my irregular polygons, this shape, this rhombus, has 4 equal sides, so it has congruent sides. However, when I look at the angles, I see that these 2 are the same size and these 2 are the same size, so there are not 4 congruent angles, okay? The difference between a regular and an irregular polygon is that all sides and all angles are congruent for a regular polygon, whereas not all sides and not all angles are congruent for an irregular polygon, even if some are equivalent. Now, you'll notice there's this word down here, equilateral polygon. So when we look at an example like this rhombus that you see, it is equilateral, meaning that it has 4 equal sides, okay? So equilateral means equal sides, but not equal angles, okay? Not equal angles. And that's really important moving forward today as we try to classify different shapes, okay? So, let's take a look at these different shapes. What are they? How can we classify them? How can we be the most specific? Okay, so the first thing we're going to look at is O. When I look at triangle O, I notice that there are 3 equal sides, so it is equilateral, equilateral, right? Equal sides, equilateral, okay? And I also notice that it has 3 acute angles. So this shape would be an acute equilateral triangle. Now let's take a look at P. So when I look at P, I notice it's again a triangle. But what kind of triangle? So I'm going to look first at the sides, and it seems like none of them are equal to me. Okay, I could get out a measuring stick and measure, but I'm pretty sure they're not equal. And then I see this angle right here, and it's definitely larger than 90 degrees, meaning it's obtuse. So I would name this one an obtuse scalene triangle. Scalene because it does not have any equal sides. Now let's take a look at S. S is another triangle, but again, this one is pretty different. I see right away, I notice that it has a right angle. It has a 90-degree angle, so I'm definitely going to name this some kind of right triangle. Now I have to look at the side lengths. What are the side lengths? Okay, when I look at the side lengths, I find that it looks pretty much to me like there are absolutely no equal sides, so that would be a scalene triangle. Now I take a look at T, my last triangle in my set of polygons. T is pretty cool because it looks like it has all acute angles, something that I saw before in O, but it also looks like it has 2 equal sides. Those 2 equal sides would make it an isosceles triangle. But now I take a little bit closer look at it and I look at this angle up here. Am I right in saying that that's an acute angle? Or should I have noticed that this itself is a right angle? Excellent. Good job catching that. So now we've seen that this angle is bigger than our 90 degrees, so we hold it to be an obtuse angle. So T is my obtuse isosceles triangle. 2 equal sides and an angle that is larger than 90 degrees, making it obtuse isosceles triangle. Now I'm going to take a look at W. The first thing I have to think about with W is how many sides does it have. So I note that it has 1, 2, 3, 4, 5 sides. Now a 5-sided figure is a pentagon, okay? We have that pent, meaning 5, okay? So we see that, and now we want to think to ourselves, is it regular or is it irregular? Remember, if it were regular, all sides and all angles would be equal. Now that we look at it, does it look like all sides and all angles are equal? I didn't think so either. So we would call this an irregular pentagon. Now let's take a look at X. Looking at X, we see that it has how many sides? It has 1, 2, 3, 4, 5, 6. All of those sides look pretty equal to me, and all of the angles also look pretty equal, meaning that we can look at this as a regular hexagon. Okay, a hexagon being something with 6 sides. Now let's take a look at Q. Q is another triangle. In this triangle, we see all acute angles, and we see 2 equal sides. So we would call this an acute isosceles triangle. Below Q, we've got another triangle, triangle R. And triangle R has 2 equal sides, and it has that magical right angle in the corner. So we'd call this a right isosceles triangle. Now let's go through the rest of the shapes. So we look at shape U, and we see how many sides. That's going to be important. We see 1, 2, 3, 4, 5 sides. It looks like they're all of equal length. We could measure to be certain. And then we look at our angles. All of our angles are the same size. So this, unlike W, would be a regular pentagon. If we look at V, we see another example of a pentagon, but this pentagon does not have all of the same angles. It has 2 90 degrees, 2 obtuse, and 1 acute. So this would be an irregular pentagon. Looking at Y, we see 1, 2, 3, 4, 5, 6 uneven sides, so we would have an irregular hexagon. And looking at Z as well, we see 1, 2, 3, 4, 5, 6 unequal sides, so we have another irregular hexagon. Now you've been able to name a variety of different polygons, including the quadrilaterals that we named last week. Today you will be seeing a set of riddles where you try to solve to figure out which one of these polygons you might be seeing. I would recommend taking a screenshot of this page so that you can refer back to it at any time that you need. As a quick review, here are the quadrilaterals that we should know. Our hierarchy begins at the top. Any quadrilateral is a polygon with 4 sides. So we see all of our lovely polygons here, all of our lovely quadrilaterals, A through G. And then we see that some of them are trapezoids, having exactly 1 pair of parallel sides. So we see here our trapezoid with 1 pair of parallel sides, okay? Or we could see parallelograms with 2 sets of parallel sides. So here are our parallelograms, right? Any objects that have 2 sets of parallel sides. Parallel meaning running in the same direction, okay? Parallel. Or we could see a kite which has 2 pairs of adjacent sides that are congruent or equal. So these 2 are equal in length and these 2 are equal in length, making this a kite. Then moving further down our hierarchy, or becoming more specific, we know that parallelograms can split into 2 different shapes. One is a rectangle, which has 4 right angles, so you can see those right angles here. Or that other is a rhombus being the shape that has 4 congruent sides, so they are all equal, but it does not have right angles. That final shape that we run into is our beautiful square, which has all of these specificities. It has 2 sets of parallel sides, it has 4 congruent angles, and it has 4 congruent sides. Okay, so maybe this is something that you want to take a picture of right now as well, so that you can use this information as you fill out your riddles further. So, I'll give you a moment to take a screenshot, and then we will move on. So, today we will be filling out some hierarchy riddles. Let's look at a quick example and then you'll get started. Riddle number 1. I have 4 sides. So you can see I had all of my shapes here together. I had all of them together, but I decided to split them up into shapes to set aside and shapes to be kept. Why do you think I chose to set aside certain shapes, and why do you think I kept the others? Well, you're right. First it starts with I have 4 sides. So I put all shapes with 4 sides onto one pile, or I thought about them. Since you'll be looking at this, use those screenshots that you took earlier, and I would just draw little X's on it as you cancel out which idea you don't want to use, and then you can erase them later when you need to look at those shapes again. Okay? Then you're going to need to name the category. So what is a shape that has 4 sides? This is called a quadrilateral. So I would name my category by writing in quadrilateral. Then I'm going to look at the next step in my riddle. So A, I have 4 sides. Category name, we already named that. It was quadrilaterals. Then I see my next specificity is that they have 2 pairs of parallel sides. The subcategory name for that I know is a parallelogram. So here I have all of my parallelograms left. I've crossed off all of the rest of these. Now let's look at what I can do for the rest. I have 4 right angles. What would be the subcategory name for something that has 4 right angles? If you said rectangle, you're on the right track. So let's take a look. Which one of these shapes have 4 right angles? Well, it can't be this one, and it can't be this one. So my shape is either A or C. So let's take a look at the last clue. I have 4 congruent sides. 4 congruent sides. What would the subcategory for that shape be called? That would indeed be my square. So I cross off my rectangle, and then I have found my answer. My answer is shape A, square. So I would write down shape A, square, in my answer box, and then I would move on to my next riddle. So today, you will call a partner, and you will look at these 5 hierarchy riddles on Seesaw, and you will be trying to solve these 5 riddles together, using everything that you know about polygons to help you solve them. When you finish that, you'll do a quick review on the properties of parallelograms from your student book. Good luck. Call your teachers if you have questions.